Okay, section 10.5 is on translations. Here's your homework that will be due on Monday. Let's graph the sine of x minus pi over 2. Let's see what effect the subtraction of pi over 2 from x has on the graph of the sine function. So let me label the quadrantal values. We've got pi over 2 here, pi, 3 pi over 2, and 2 pi. And then the range of the sine function is from 1 to negative 1. So let me start by graphing the sine function in blue. So we'll just graph the sine function in blue. And by this point, you know what the sine function looks like. That's going to look like this. And in order for us to graph the sine of x minus pi over 2, let's turn to our table here. So here's our input values for x. We're going to put these in for x, so we're going to subtract pi over 2 from the input value and then determine the sine of that value. So when x is 0, we're looking at the sine of 0 minus pi over 2, or the sine of negative pi over 2, which is negative 1. When x is pi over 2 minus pi over 2 is 0, so the sine of 0 is 0. When x is pi, sine of pi minus pi over 2 becomes sine of pi over 2, which is 1. When x is 3 pi over 2, subtract pi over 2, we're now looking at sine of pi, which is 0. And the sine of 2 pi minus pi over 2 is the sine of 3 pi over 2, which is negative 1. So let's plot these points. So at 0, we're at negative 1. At pi over 2, we're at 0. At pi, we're at 1. At 3 pi over 2, we're at 0. And at 2 pi, we're at negative 1. So the graph looks like this. Okay, so what it looks like is that plugging in x minus pi over 2 for each x moves the graph of the sine function pi over 2 units to the right. Take a look at this. If you take the sine graph, which is in blue, and if you shift it to the right pi over 2 units, it looks like we're smack dab on top of the graph of sine of x minus pi over 2. Let me move this back. And we will just say this, that plugging in x minus pi over 2 for x moved the graph pi over 2 units to the right. Pi over 2 units to the right. So, if you want to think of it this way, think of the new origin. We replaced x with x minus pi over 2. Set that equal to 0. Solve for x and you get x equals pi over 2. Think of that, pi over 2, as your new origin. Your new origin. So kind of like where the y-axis was, it's now here at pi over 2. Okay? Now, let's see what happens when I replace x with x plus pi over 2. Again, let's graph the sine function in blue. Let me label the quadrantal values. 2 pi, pi over 2, 3 pi over 2. This over here will be negative pi over 2. This will be 1 and negative 1. So let's graph first the sine function, and let's graph it from negative pi over 2. It's from 0 to 2 pi. So the sine function looks like this. One full cycle of the sine function. Let's do the same thing we did with the previous example. To graph the sine of x plus pi over 2, let's plug in these input values, plug in those values for x, and find the output value. So when x is 0, we're looking at the sine of pi over 2, which is 1. When x is pi over 2, we're looking at the sine of pi, which is 0. When x is pi, we're looking at the sine of 3 pi over 2, which is negative 1. When sine is 3 pi over 2, we're looking at the sine of 2 pi, which is 0. And when x is 2 pi, we're looking at the sine of 5 pi over 2, which is 1. So let's plot these points. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi, 1. So the graph looks like this. And if I were to continue it to the left of the y-axis over to negative pi over 2, that's what it would look like. Now look at what's happening here. When we replaced x with x plus pi over 2, it looks like what we're doing is we're taking the graph of the sine function, the blue graph, and we're just shifting it to the left pi over 2 units. To the left pi over 2 units. So what we can say is this, that this graph, plugging x plus pi over 2 for each x, move the graph pi over 2 units, this time to the left, to the left. And again, if we want to talk about the new origin, let me go down here in the bottom left, I've got more space. When we replaced x with x plus pi over 2, to determine the new origin, set the x plus pi over 2 equal to 0 and solve for x. Now it's like your new origin, or at least the x value of your origin, is at negative pi over 2. So the new y-axis is kind of over here at x equals negative pi over 2. So let's generalize here. In general, for any equation, plugging x minus c for each x moves the graph c units horizontally. Now, if you want to determine in which direction, let's do this. Remember what we did. Take x minus c, which is what you're replacing x with, set it equal to 0 and solve for c, and x equals c becomes your new origin, if you will. Becomes your new origin. So x equals c is called a phase shift. So in algebra, we called movement horizontally horizontal translations. In trig, we call horizontal translations phase shifts. Okay? Now let's look at this next example. Y equals sine of x plus 3. Y equals sine of x plus 3. So what's going on here is, let me go ahead and label the quadrantal values. Pi over 2, 2 pi, pi, 3 pi over 2. This here is 1. You know, I guess down here would be negative 1. 2, 3, and 4. So again, let me graph y equals sine of x in blue. From 0 to 2 pi, again, you've seen this many times, looks like this. So you know, if I'm going to graph y equals the sine of x plus 3, you know from algebra what that plus 3 does. It takes each of our previous output values and adds 3 to it. So when x is 0, the output is 0. Now the output's going to be 3. When x was pi over 2, the output was 1. Now it's going to be 4. When x was pi, the output was 0. Now it's going to be 3. When x was 3 pi over 2, the output was negative 1. Add 3 to negative 1, and now the output is 2. And lastly, when x is 2 pi, the output was 0. Now it's going to be 3. So the graph of y equals sine of x plus 3 looks like this. And I think we can all see what that plus 3 did to the graph of the sine function. It took the sine function and it shifted it vertically 3 units up. It shifted it vertically 3 units up. Okay? So again, let's generalize here. Let's generalize. In general, y equals f of x plus d, move the graph d units vertically. Okay? So, y minus d equals 0. Again, solve for y, you get y equals d. This becomes, again, your new origin. This becomes your new origin. So if you go back to the previous example, think of this, rather than y equals sine of x plus 3, y minus 3 equals sine of x. So y was being replaced with y minus 3. So we set y minus 3 equal to 0 and solve for y, and you get y equals 3. So that's why I've got that horizontal line through y equals 3. So that's serving kind of as your new x-axis. Kind of as your new x-axis. Okay, we'll move on to part 2 in a separate video.